Welcome to Summarize Science, where we look at how researchers are making robots more adaptable. Imagine training a robot to pick up a cup, but then you move the camera slightly and it completely fails. This is a massive problem in robotics because traditional AI models are extremely sensitive to camera placement. Researchers have introduced VistaBot, a new framework designed to solve this specific bottleneck. The paper highlights that even small changes in perspective can lead to dramatic policy failures. As shown in the first figure, standard models drop to nearly zero success as the viewpoint deviates from the training condition. To address this, VistaBot merges feed-forward geometric models with video-generating AI. Instead of needing a perfectly still camera, it uses view synthesis to adjust its perception on the fly. The system works by taking a new, unseen camera view and using 3D math to project what it thinks the training view should look like. It utilizes a geometric model to estimate depth and relative camera poses without requiring manual calibration. This architecture allows the robot to lift simple 2D observations into complex 3D point clouds. Essentially, the robot is creating a mental map to correct its perspective in real time. When the robot encounters gaps in its vision due to objects being in the way, a video diffusion model paints in the missing details. This process, called point rendering in painting, ensures the robot has a visually coherent scene to work with. A memory module is even included to help the robot remember previous frames, keeping its movements smooth. They tested this system against state-of-the-art models on 8 different manipulation tasks in a simulation called RL-Bench. These tasks ranged from closing a laptop and grilling meat to handling a toilet seat. The results showed that VistaBot improved success rates by over 2.5 times compared to previous models. While older models failed when the camera moved 45 degrees, VistaBot maintained its performance. The researchers also introduced a new metric called the View Generalization Score to quantify this robustness. Visual comparisons demonstrate that the imagined views created by VistaBot are much sharper and more accurate than other methods. To prove it works beyond just simulations, they set up a real-world experiment with a Franca robotic arm. The robot successfully performed tasks like picking boxes and placing bananas even when the cameras were at different angles than during training. A visualization of the data shows how VistaBot-generated views align closely with original training data, preventing errors. This means robots won't need tedious recalibration every time someone accidentally bumps the camera setup. To recap, the researchers combined 3D math with generative video AI to create a view-robust robot system. In the future, this could lead to general-purpose robots that learn a task once and can perform it anywhere. It bridges the gap between high-quality computer vision and practical, everyday robotic control. Thanks for watching this summary of cutting-edge technology on Summarize Science.